everyone! Welcome to the bonsai capital of the Philippines, the municipality of San Isidro, Davao Oriental. I am Hannah May M. Rivera, senior high school student of San Isidro National High School. I am your math tour guide for today. I will guide you how to solve math problem while having a tour in the beautiful places here in Davao region. Our first destination, Mount Tamigitan World Heritage Park. Oh no! What happened here? Here is the problem. A small portion of the area of Mount Tamigitan had a soil erosion due to heavy rains. In order to prevent further damage, an erosion control netting is proposed by the LGU of San Isidro. The area of the region where the soil eroded is bounded by the curve y equals x squared and y equals negative x squared plus 4x. How many square meters in thousands of a net is needed to cover the area of the region where the soil eroded? Erosion control netting is a preventive measure to reduce soil erosion. This practice is used to areas that may erode near structures, such as homes, roads, and bridges. Going back to the problem, here are the following steps on how to solve the problem. Step 1. We need to find first the points of intersection of the two curves. But how do we do this? Worry no more! Since an ordinary scientific calculator cannot process the data, we need to use a graphing calculator. Here are the steps on how to graph using graphing calculator. First, press on. As you can see in the screen, there are several options to choose from. From the menu, press 5 for graph. Next, we enter the first function in y1 by pressing variable key x squared, then press execute. Next, we enter the second function in y2. Press negative variable key x squared plus 4 variable key, then execute. To see the graph of the curves, press F6. And there you go! Here is a closer look of the graph. To find the points of the intersection of the two curves, press F5, then F5. Use the navigation key left and right to see the points of intersection. To show the coordinates of the intersection, press execute. We can see that 0 and 0 and 2 and 4 are the points of intersection of the curves. You see, with the use of this graphing calculator, we were able to see the graph in no time. Now, step 2. We will solve for the area of the region bounded by the two curves. Let f of x equals negative x squared plus 4x and g of x equals x squared. Observe that in the interval 0 to 2, the curve y equals f of x is above the curve y equals g of x. Hence, the area of the region bounded by the two curves is defined by a equals the integral of f of x minus g of x dx, evaluated from 0 to 2. From this equation, substitute f of x and g of x. Simplify. Then, evaluate from 0 to 2, and we see the area of the region, which is 8/3, or approximately 2.6666 square units. Now, here's the trick. We can solve the area of the region bounded by the two curves without going through the lengthy process. How? With the use, of course, of a graphing calculator. Aside from graphing functions, a graphing calculator can also be used to calculate the area of the region bounded by the functions. Now we will find the area of the region bounded by the two curves. We press F5, Shift, F5, F6, F3, F3, then execute. To see the bounded region, use the navigation key left, then execute. Use the navigation key right, then execute. And there you go! The area of the region bounded by the two curves is 2.6666. Same result to what we have solved earlier. Only that it is more efficient, easy, and accurate when we have the knowledge in using a graphing calculator. Just imagine the time and effort you need to exert in graphing and solving without this graphing calculator. Amazing! Step 3. Finally, we state the conclusion to our problem. Therefore, the area of the region to be covered by the net for soil erosion control is 2,666 square meters. Problem solved! In my next video, we will visit the magnificent Aliwagwag Falls in Katiil, Davao Oriental for another math adventure. This has been Hannah May M. Rivera, your math and tour guide. Thank you for watching!